This is page 9 of exponentials. Just before we start, I'd like to remind you that if you have a base with an exponent like that, that this is basically you can like have the exponent here multiplied together, like this 3 and a fourth. We have it multiplied together. Here we have the same fraction, but it's broken up into two factors. So you could have it as 2 to the 1/4 to the third, and it's also the same thing as 2 to the third to the 1/4. We've studied that in the last couple days. So just remember, you can reverse these exponents in a different order whenever it's convenient for you. You can multiply them together, you can factor them. Okay, so let's start on the first one. It says to factor this expression here. I'm going to show you two ways to do it. One is that you recognize that this is very similar to this, and if I just reverse the order of the factors in the exponent, instead of 2x, I put x2, that now it looks very similar to this. I'm going to put parentheses around the 5x here, and then now you can see that I have the same thing in both places. So now if I factor it, I could say that this is something squared, and this is just something. If I factor out the something, then I would be left with 5x here, and then I would be left with 1 here, because I factored out a 5 to the x out of each thing. Okay? Now, if you didn't really get that, then I'm going to say to put in one intermediate step. Once you rearrange the 2x so that it's x squared, and you kind of can see that the base expression here is 5 to the x, you're going to replace the base expression with something else. Okay? So I'm going to replace it with a happy face. Okay, so now I have happy face squared plus happy face. And now I'm going to factor out a happy face. If I factor out a happy face from happy face squared, I'm going to have happy face. If I factor out a happy face from just happy face, then I'm left with 1, right? Because 1 times happy face is happy face. Happy face times happy face is happy face squared. Okay? If you want to, you could just use t or some other boring variable like that. Okay? Now that I have it factored, I'm going to replace the happy faces back with 5 to the x, because that is what happy face represents. So I'm going to put 5 to the x, 5 to the x plus 1, and now that you can see I have the exact same thing as that. Okay? So you could either recognize it right off and just factor it out as an expression, or you can replace the expression with a happy face, and then maybe it's easier to see that you are factoring out certain elements. Okay? The other thing that you might want to do is, if you don't like the happy faces, you might want to just replace it with a number. So like if I have 5x squared plus 5 to the x, let's say I'm going to replace my 5 to the x with a number like 3. So now I'm just going to have 3 squared plus 3. Now if I'm going to factor this, I would say 3, and then I would factor the 3 out of 3 squared, so I'm left with 3. I factor out the 3 from the 3, and I'm left with 1. And then I'm going to replace the 3's back with 5 to the x. So now I'm going to get 5 to the x times 5 to the x plus 1. So that's essentially what I'm doing with the happy faces there. Okay? I'm using them as a symbol just to represent the 5 to the x, because 5 to the x is intimidating. Alright? Alright, let's try C. Okay. So I can immediately see that I have the 3n here. If I reverse it, I can make it look more like the first expression, 7 to the n. So I'm going to reverse it. And if I reverse it, then I can put parentheses around it, and now I definitely have two expressions that are the same. I'm going to replace those expressions with a happy face. So I have happy face plus happy face cubed. Now if I'm going to factor out a happy face, I'll get happy face factored out, and the first term, I'm going to factor out the happy face, I get 1. The second term, I factor out a happy face, and I get a happy face squared. So now I have this expression here. Now I can replace the happy face back with 7 to the n. So now I'm going to have 7 to the n, 1 plus 7 to the n squared. Okay? All right. Let's do e. So I have 6 to the n plus 2 minus 6. Okay. So in this case, it looks like my common expression is just 6 to the first, maybe. Okay. So let's see. I have 6 to the first on the right side. On the left side, do I have 6 to the first somewhere here? Well, remember that if I have 6 to the n plus 2, that's the same thing as 6 to the n plus 1 plus 1, right? Now, if I take this expression and I change it into multiplication of exponential expressions with the same base, I could put 6 to the n, 6 to the 1, 6 to the 1, minus 6 to the 1. Now I'm going to factor out 6 to the 1. If I factor out 6 to the 1 now, I'm left with 6 to the n, 6 to the 1, and I factored out this 6 to the 1, so I don't repeat that one. And then I have minus 1 here because I factored out 6 to the 1 from here. And now I can rewrite this one final time. I don't have to write 6 to the 1 because it's just 6, right? And then 6 to the n times 6 to the 1, I could rewrite it as 6 to the n plus 1 minus 1. Okay? And maybe when you looked at this, you could already do it all in one step. Okay? But if you can't, go ahead and do all the steps that I did here. Okay. 9 to the x minus 4. Okay. So, some people might recognize 9 to the x and minus 4 as that famous SAT problem, a squared minus b squared is actually equal to a plus b times a minus b. Okay, so how can we rearrange it that way? Well, there's a reason why they're using 9 and 4. They're using 9 and 4 because they're squares, okay? They're squares of 3 and 2. So I'm going to say 9 to the x is actually 3 squared to the x. 4 is actually 2 squared. It almost looks like this now. One more step. I'm going to reverse the order of the 2 and the x. So I'm going to have 3x squared minus 2 squared. Okay, now it really looks like that. Now I'm going to factor it out. So I can factor this out as 3 to the x minus 2 times 3 to the x plus 2. Okay? If you don't see that immediately, then what you could do is you could say, oh, 3 to the x is going to be happy face. 2 is going to be sad face. So, happy face squared minus sad face squared is equal to happy face minus sad face times happy face plus sad face. Okay? All right. All right, let's go to C. Ooh, here we are again with some suspiciously square-like numbers. I have 16 and 9, which are both squares. So they must mean for me to replace the 16 with a 4 squared. I'm going to replace the 9 with a 3 squared to the x, right? Then to make this into something squared, I'm going to reverse the order of x and 2. I'm going to say 4 squared minus 3 to the x squared. So now I know I can factor this into 4 minus 3 to the x times 4 plus 3 to the x, right? A squared minus b squared is equal to a minus b times a plus b. Let's do E. Oh, here we are again with 9 and 4, some suspiciously square-like numbers. So we're going to put 3 squared to the x minus 2 squared to the x. Then I'm going to reverse the order of these so that I have a squared minus b squared. So I'm going to have 3 to the x squared minus 2 to the x squared, which is equal to 3 to the x plus 2 to the x times 3 to the x minus 2 to the x. Okay, let's do g. Once again, we have a lot of expressions that look like squares. So I'm going to replace 9 to the x with 3 to the 3 squared to the x. Then I'm going to put, instead of 25, I'm going to put 5 squared. Okay. And oh, now when I look at it, the 10 is actually suspiciously looking like 2 times 5. All right, and there's a reason why it looks like that. So we're going to reverse the order there. So we're going to have 3 to the x squared plus 2 times 5 times 3 to the x plus 5 squared. Okay, now I'm going to replace all the 3 to the x's with a's. I'm going to replace the 5's with b's. And the reason why is I want you to recognize that this is an expression we know how to factor. If you have a squared plus 2ab plus b squared, that is equal to a plus b squared. Go back a few pages and look at our review of famous factorables. A plus b squared. Now we're just going to replace back. We replaced 3 to the x with a's, right? 3 to the x with a. And we replaced the 5's with b's. So now we can replace them back. So the a was 3 to the x. The b was 5. Right? All right. I. Ooh, the 25 looks like a 5 squared, doesn't it? Minus 4. 4 looks like a 2 times 2. Times 5 to the x. The 4 looks like a 2 squared. So once again, we're going to invert the order here. So we're going to get 5x squared minus 2 times 5 to the x plus 2 squared. The 2's here we're going to replace with b's. The 5 to the x's we're going to replace with a's. We're going to get a squared minus 2ab plus b squared. This factors into a minus b squared. So the a is 5 to the x, the b is 2 squared. Okay, and let's go to the next section, last section. 3a. So we have 4 to the x, which looks like 2 squared to the x, plus 9 to the 2 to the x, plus 18. Now we're going to reverse the order of the 2 and the x here. So we're going to get 2x squared plus 9, 2 to the x plus 18. Now what I'm going to do is I'm going to replace the 2 to the x with a variable, happy face squared plus 9 happy face plus 18. You know how to do these kind of factoring problems, right? You list out the factors of 18, and then you figure out what combination of factors is going to add up to be 9, right? So it's going to be 3 and 6, right? Happy face plus 3 times happy face plus 6 gives you happy face squared plus 9 plus 18, because the inside multiplication gives you 3 happy face, the outside multiplication gives you 6 happy face, which is 9 happy face. 3 times 6 is 18. Everybody's happy. Now we just need to replace the happy face back with 3 to the x. And we're done. Okay? Alright, let's go back to C. We have 9 to the x plus 9 times 3 to the x plus 14. We know that 9 to the x is actually 3 squared x, which is actually 3 to the x squared. 3 to the x squared plus 9 3 to the x plus 14. And then we can factor this. It would be 3 to the x, 3 to the x. And I think that 14, the only real factors are going to be 2 and 7. So we'll go ahead and put that. Let's see if that works out. Yeah, the inside, 2 times 3 to the x plus 7 times 3 to the x does give us 9 to the 3 to the x. So that is the factor. Okay? remember that you can do these with quadratic formula, right? If you have a equals 1, b equals 2, b equals 9, c equals 14, if you put it in the quadratic formula, it will give you that the two factors are -2 and -7. So that'll tell you that you could put those in like that, okay? All right, let's see. Last one. 25 to the x is equal to 5 squared x, and then 5x and minus 2. 5 squared x is actually 5 to the x squared plus 5 to the x minus 2. And let's replace the 5 to the x with a happy face. So happy face squared plus happy face minus 2, we can factor that. It would factor into -2 or +2 minus 1, right? If we multiply +2 minus 1, it gives us -2. If we do the inside, 2 happy face minus 1 happy face is indeed 1 happy face, so that worked out. So we're going to replace back the happy face with 5 to the x, so our answer is 5 to the x plus 2, 5 to the x minus 1. Okay, and that's it for this page.